Hi guys, welcome to this video review for your semester exam. By student request, some kids asked about this one and wanted me to discuss a little bit the properties of kites. So let's have a look at some of the things that are true about kites in geometry. I'll sketch one down here below. Okay, a couple of things. First of all, you notice that this is not a parallelogram because there are not two sides parallel. This is also not a trapezoid family member because there isn't even one set of sides parallel. So that's one thing that's, first of all, different and out. Second thing you'll notice from the labels here, of course, that sides are equal and next-door neighbors. And the same thing is true here. So that is always true of kites. Something else that is true of kites, the angles out here on the edges, or the wings we could call them if you're thinking about it, the actual kite that flies, those are always congruent to each other. It sure looks like they ought to be, and that's actually the case. If you do, however, look at the other angles, that would be at the top and the bottom of your flying kite, those are not equal, and they should not be if this is a kite. We could even draw a kite that's a little more severely distorted, and then it's much easier to see that the top angle and the bottom angles here probably shouldn't be equal. But these two side ones, and I guess if your kite is going to fly well, those do need to be exactly the same. So that's a couple things about first of all, the definition of a kite. It's a quadrilateral with consecutive sides equal to each other in pairs. No parallels at all. Second thing about a kite, let me see if I can erase some of what I have going on here. There we go. I'll draw another one. And now we'll talk about the diagonals in a kite. There's some interesting relationships there too. So let me sketch one here quick. And now the diagonals. Does this sideways diagonal divide this kite into two equal triangles? Pretty obviously, no. Does the vertical one from top to bottom divide it into two equal triangles? Here the answer is actually yes. So that's one thing that happens. Left and right, we have two triangles that happen to be equal to each other. As a result of this, it's pretty easy to prove that this angle up here and this angle up here are equal, right? Because those are corresponding parts in congruent triangles. As a result, if those two are equal, then we know that this particular, I guess we can call it a vertical diagonal, actually is an angle bisector up top. And by the same thinking, that these two angles from triangle 2 and triangle 1 are equal to each other because they are corresponding parts of congruent triangles. They're also congruent. That means that what's going on down here is this diagonal, that I'll trace over one more time, is also down below here an angle bisector. Now I see up above in the problems they gave us, none of these things are asked about. They haven't got the diagonals drawn in. But that is something to notice as we go. Also, of course, as usual, since this is a four-sided figure, all of these angles added together, of course, will get our famous total of 360 degrees. So some of those properties should help you answer the questions above. For example, in number 48, now, if you find those wing angles, I call them, those side angles, which I highlighted down here in blue, those have to be congruent. So right away you can pencil that guy in. And then by subtraction from 360, actually add the other two together and solve for y. In 49, you have something similar happening. Here is our other wing angle over there on the edge. That must also be 94 degrees. So then to solve for the y angle, it's a very simple matter of using your 360 total. Last thing they ask about that I see is this side length A over here. Boy, if we knew this one, that would be an easy answer, but we do not. The only other thing we could add is that this side up top here must be 15. But the other information they give you that some kids might miss is the fact that the perimeter is 90. So once you have a 90 perimeter in mind, you can simply add up all of the sides a plus 15 plus 15. Those are supposed to be 15s, and those are supposed to be plus signs. Equals 90, and do your math work to come up with your answer for that one. So that's a little more help and information about this last page of your review on kites. This was one thing that I was not here to help you get. So maybe go back and have a look at your Blackboard resources. Watch a video or two for some other explanation about kites and some of their properties. Thanks. Good luck on your exam.